Hello, everybody. Welcome to the third installation of 272 Summer CAD Class. My name is Phil Simonowski. I'm an alumni of 103, mentor of 272 and 14133. I'm an engineer designing robotic systems, and I've been involved in FIRST for over 15 years now. And I use SolidWorks and Onshape just about daily, one or the other, both at work and Onshape for my own personal projects and robotics. And we have Emily as well. Would you like to say anything, Emily?
Hi, I'm Emily. I've been a part of Team 272 for the past 5 years, and I just graduated from Lansdale Catholic.
Perfect. Remind me, Emily, next time that we'll make a slide for you specifically if you'd like as well.
That's okay. I don't need one.
Okay. All right. All right. So today's goals, we're going to do much more work with constraining and 2D sketching. So we're going to kind of build on that knowledge that we kind of just instantiated on last class. We're going to make some more complicated sketch. We're going to talk about when to use certain constraints and when to use other constraints, or when to dimension over when to constrain, or vice versa. And then we're going to learn how to use variables in sketches, how to actually utilize variables in sketches, create and utilize variables. We're going to do a little bit about version control and branching. And we're going to create the first version of our file. And we're going to learn how to revert to a previous version of our file. And then we're also going to learn about configurations and when to use them. A configuration is like if you have a part that has similar features, but it has different dimensions. A configuration will allow you to use all the same features and just change the dimensions of that part. Really, really helpful for making a lot of parts very quickly. And then we're also going to have a engineering conversation about torque. And then we're going to relate that conversation to shafts, bearings, and hubs. And both of those presentations are going to be from what team is that again? Team 3005, the Robo Chargers. They just have an awesome presentation of like all the stuff that I would cover anyway. So I'm not doing twice the work, and I'm giving them all the credit because they deserve it. So yeah, we're going to go move on now. So I want to give a little bit more info and tips and suggestions on 2D sketches. And the one that I want to recommend that everybody learn how to use and get familiar with is when you drag and when you click and drag in Onshape, when you click and drag to the right versus when you click and drag to the left, you will select different things, and it's important to know the difference. So I'm actually going to make this image larger, and I'll probably do a little demonstration in Onshape too. Let me bring this to the front. So this is just a little animation of that somebody from the Onshape team recorded. So if you look, when this person, their name's Cody, when they click and select to the right, they only are selecting the things that are fully within the box, completely within the box. Now, when they click and select to the left, they select all the things that are even touching the box. And it's an important distinction. It'll allow you to more correctly and easily select the geometry in your sketches that you want to select. You can also help yourself by rotating your sketch. You can change your perspective on your sketch and click and drag things in different positions. You'll see me do different versions of this when I am drawing and giving demonstrations as well. But it's just a really kind of useful thing that I do all the time, and that will help you save thousands of hours of clicking and selecting individual lines or selecting the wrong thing. So that's a good one. In Onshape, you don't need to control click to select multiple things. You can just click them, and then to unselect them, you just click them again. It's kind of intuitive. In things like SolidWorks, you have to Control Shift to select things, and then Alt Shift to deselect things. It can get a little bit more confusing, and sometimes if you misclick, like in SolidWorks, if you click off of that, it'll then remove your entire selection, and then you're like, oh man, I selected 20 lines. That's frustrating. And then another one is you should only be sketching one side of a symmetric feature of any kind of symmetric thing. So let me give an example of that. Something that's symmetric. So I have my phone here. This probably isn't the greatest example, but your phone is symmetric actually in two directions. It's symmetric sometimes, not always, but it's symmetric this way and it's symmetric this way. And it's not always symmetric that way if you look at the back. You could still start the model in a symmetric way, and then you can add that feature later after you've done the symmetry portion of it. So for my phone, for it being symmetric, I would probably make a center line this way and then a center line this way. And I would only draw this upper corner of the phone. And then that way I could take whatever I do up in this corner and mirror it over here. And then whatever I do on the top there and mirror it down. And that just helps. That means you'll only have to change like of 1 or 2 dimensions to adjust the entire geometry of the whole thing. I'll go into plenty more examples of this when we get into Onshape and such. But just think about all your lines of symmetry in your sketches. That would be my high suggestion. You can use information from other sketches and like draw a circle on a corner or on another point that exists in another sketch. That is something that you can do. You don't always want to do that, but you often do want to do that. So we're going to talk a little bit and do some exercises surrounding when you would want to use that geometry, when you would not want to use that geometry. In Onshape, they have this cool feature that exists in SolidWorks too. It's called the shortcut key. And what the shortcut key is, it brings up a little window with a couple of few specific features that instead of clicking the top bar or searching the top bar constantly for the things you want to do or click or use, you can just click S and those few things show up. So let me get into, I think I have Onshape open somewhere. So when I'm in this part studio, when I click S, this window shows up and it has create a sketch, extrude, revolve, chamfer, fillet, hole, mirror, planes. And these are all common things that I use. And I can customize this. So I can put different features in this thing. Like I can choose what features I want right in here. These are just the ones that I found most useful and that I use all the time, but you can add more. You can add variable, you can add make connector, you can add just about anything to these shortcut toolbars that you would like. And they're different if you're in a part studio compared to if you're in assembly. You see how the assembly one is different. The assembly one is like insert a part, mates, patterns, and groups. And we'll go over those later when we get to assemblies. And then it's also different when you're in a sketch. So when you're in a sketch, it does sketch things. So you can see I have line, rectangle, center point, rectangle, circle, cut, dimension, slot. All those are things that I've added onto my little shortcut toolbar. And again, that's through the letter S. So if you're in an Onshape document anywhere and you're in this window here and you click S, you will see this pop up. And I'm going to do a little demonstration with the right select and left select while I'm here as well. So if I click up in the upper left and drag down, and I select this, I am not going to select the bottom line. Even though the bottom line is partially in my selection, I'm not going to be able to select the bottom line because a right select only selects lines and geometry that is fully within the box. So if I let go, I'm only selecting these 2 lines here. I did not select the bottom line. But if I do that same selection from the top right and down, like this, drawing to the left, like creating the rectangle to the left, I will be able to select all 3 lines, anything that's just touching the box, even if I don't have it fully selected. So like if I move over to here, I'm going to select this angled line as well. And a good example is if I select the whole thing, except for the far right line to the right with a right select box, I won't select the upper or the lower line. Whereas if I do the same selection from the bottom right or from the top right to the left, I will select all 3 of those lines except for the far right. And again, you can help yourself by rotating your sketch. So if you want to select like all of these things except for maybe that line, you can make your life a little bit easier by going like this. And now I can left select and not select that thing, that little line over there. Or if I only want to select these 2 lines, I could just right select. If I only want to select this line, I could just that. And do remember, you can also just click to select lines or points. You don't always need to draw a box around it. So if you only need to select one line or curve, you can just click to select it. And the same thing goes for points. I believe when you left select or generally box select, it doesn't usually get corners. It usually just gets lines or points. So if you did want to do and select a point, you have to individually select points. Cool. Any questions about any of that? And then while you're selecting things, to deselect something, you can click off of the object, like in the white space, or I believe it's the space bar in Onshape will clear your selection. I think it'll actually clear what feature you're using. No, it doesn't clear whichever constraint you're using, but the escape key will clear your selection and whatever selection you're using. Oops, I click F1 instead. So spacebar clears your selection. I just hit the spacebar and I clear my selection. And if I select a feature or if I select a constraint, the escape key clears the constraint. So you're going to be using escape and spacebar fairly often. Another quick tip, I always recommend CADing and really doing any computer program with 2 hands. Using the shortcuts in computer programs will save you hours and hours and hours of time over the course of your time doing it. It'll just allow you to be faster, more efficient, and get more work done in less time. And that's especially true during like a robotics build season where you have a very, very, very short amount of time to design an entire robot. You want to be able to really, really quickly pump out designs and learning those shortcuts and getting familiar with them without needing to constantly look them up is a big help. Another quick tip, we want to watch out for implied constraints. So those are constraints, I believe. Oh, one second, let me go back. I believe this little animation is showing that. It's showing Onshape generating implied constraints. So yeah, so it might be a little bit hard to see, but there's these little tiny yellow dotted lines that appear. And it's also creating implied vertical and horizontal constraints for some of those things. And you can also create, if you do want to make an implied constraint, you can go over to a point and kind of force it to imply a constraint. And that's what's going on in this image here. So I'm going to do a little demo of that while we're here. Oh, beautiful. So if I draw another line, I just click over here without mousing over anything, I have no implied constraints on that point, right? Like I can move this anywhere. But if I first mouse over this line and then come up, do you see how it creates that little dotted yellow line? And it shows the vertical constraint? That's called an implied constraint, or it's going to automatically create that constraint for you. And it'll do horizontal as well, in either direction, up or down. And now if I mouse over another point, it's going to switch my preference for my constraint. It'll actually add both. So now I can be horizontal from that upper line and vertical from that lower one. If I come down here, it'll also imply the constraint as well. So if you do want something to be relative to some other point, you can make your life a little bit easier and not need to create as many constraints by creating these little implied constraint lines. But sometimes you don't want them. Like maybe I want to make this line not right there. Well, now that I've already made it, I have an option to either just delete those two constraints, or I could instead just delete the entire line and start over again without mousing over the points. It's like now I can start. Now we won't have implied constraints. So implied constraints are helpful. They help save time, and they assume that you want constraints in certain places, but sometimes you don't want constraints there. So just be aware of that. All right. What is that? That must be lavender. That is beautiful. Oh, you can press Shift to lock the constraints that are in view. This is something that I recently learned in Onshape, and this goes along with using your shortcuts for things. If I mouse over this corner, it'll show that I have this coincident constraint. In this corner, it will also show the coincident constraint. But if I click like here, if I hold Shift, now wherever I put my mouse, it'll show these constraints. So I'm holding the Shift button now. It might not be clear, but and I can mouse over other lines, and then it will show all their constraints as well, or other points. That's really helpful if you're struggling with finding the constraint that's causing issues, or what is constraint to what. And also note that when you mouse over a constraint, it highlights the two things that are constrained. So like this equals, it shows you that those two lines, those two yellow lines now, are the constrained lines. And the same thing with the perpendicular, and this perpendicular, and this coincident, showing you those two lines, the endpoints of those two lines are coincident. So there's a lot of kind of visual highlighting that Onshape does that helps you understand what your constraints are doing and where they're coming from. There is also the option to just show all the constraints in the sketch. So as long as you have this window open here, you can just click Show Constraints, and it will show all the constraints. What's interesting is that it looks like the Shift permanently keeps that open. Interesting. I'll have to mess around with that a little bit. Oh, it might keep it open until you click outside. Oh. I'm going to do sticky keys or something soon because I'm clicking so much. All right, so that's a little bit about showing constraints and understanding constraints. Oh, it looks like it goes away just after a timer. That makes more sense. Like I said, I just learned this feature like a couple days ago. So I'm still learning how to use it, but it looks like they just go away after a timer. All right, next is the cut and slot features. These are really, really useful when you're sketching. A slot is kind of a more complicated thing to sketch because you have to make all the circles tangent with the end. But instead of doing that, you can just create a line of wherever you want the slot's centers to be. You select the line and you click the slot button, which is right here, or I have it in my shortcut bar. It looks like this. and it'll automatically create a slot around that line for you of a certain size. Now, if you see, I have a little green mouse button. It shows my little mouse, and it has a little green checkbox there. That means that I have to click to confirm to make the slot. If I didn't click to confirm to make the slot, I'll show you what happens. Click slot. If I didn't click, if I click like escape, or if I clicked outside of the thing, then it won't create the slot. It'll stop the slot creation. So you have to do slot and then click, and it'll create it. And now I have a slot, and now I could change the diameter of the slot. I can make this inside line just... Oh, let's talk about construction geometry. I don't think I've talked about construction geometry yet. So when you see dotted lines in sketches like this, when you create them, it means that that is geometry in your sketch used to tell you where things are located, but it's not actually used to define the profile of something. What do I mean by that? So do you see how these are closed objects? And when I click on them, I can actually select the area that's inside of them. Well, if I make this side a construction geometry, I no longer have a closed area that I can click inside of it here. This is an open object because it doesn't really see this as a solid line. It sees it as just a temporary... It's almost like a open wall, or like a glass wall. Think about it that way. Whereas we need solid walls like this in order to actually extrude or revolve geometry. We will be using these dotted lines, these construction geometries, a lot to generate the locations of different things. An example of that is like the center to center distance on chains. The distance from one center of a chain to another center of a chain is really, really critical to get right. And so what we'll often do is draw a line between the two and dimension that line, even though we don't want that line in our actual robot. Like, we don't care to have that physical line there. We just want to know that that distance from there to there is a specific distance. And that's what construction geometry is used for. So if you ever see dotted lines, know that that's for construction geometry. The button for that is right up here. It shows like a solid line, and then it shows a dotted line. It shows arrows pointing between the two. And the shortcut for that is Q. That is probably one of my most used shortcuts when I'm sketching, switching something between construction geometry and real geometry. Super useful. It's really quick. It's right next to, it should be right kind of where your hand's resting when you're sketching anyway. So it's right there. Use it. Super useful. All right, let's go back. All right, any questions about any of these features so far? Any of these little tips and tricks? All right, we're going to just do a little bit more stuff here, talking about variables. So I showed you that you can use a variable to define things in the last class, but I'm actually going to show you how to create it a little bit better here, and a little bit more important information about it. Variables are a feature in the feature tree, which means that the order in which variables are created is important. For example, you can't have a sketch that uses a variable and then define the variable after the sketch. The sketch at that point doesn't see that variable in existence, and it goes, I don't know where the variable is. And I'll do a little quick demonstration of that. So I'm going to finish here, and we have this length value, right? 50 inches that I've created. And let's make this that variable, and how you assign it is the hashtag and then the variable name. So hashtag length, or pound sign, I guess. I'm using hashtag because that's what most of your generation knows them as. Pound sign length, and you hit enter, and now that dimension is 50, which is what the variable is equal to. And if I leave the sketch, I can now come in and I can change this 50 to maybe say 25. Now it changes the scale of that object. This side's now 25 inches long. By the way, you can click on any line or any 2 points, and it will tell you the distance between them in the bottom here. where you can also click the measuring tool, and this nice little measuring window comes up and tells you all the different details about how far they are from each other in a straight line, how far they are in the X, the Y, the Z, so on and so forth. You can change units right here. You can change what measurements you want to show. Super, super useful. Looks like a little tape measure in the bottom right. That's if you click on any line. So, but now, because the sketch uses this variable, if I accidentally change the order by clicking and dragging this variable down below the sketch, it's going to yell at me and it's going to say, where'd that variable go? It no longer exists. That's because we're now creating that variable after the sketch. So if I open the sketch, it's going to give this red here. And it's saying, I don't know what this length number is you're talking about because it hasn't been created yet, right? It doesn't exist. Basically, it thinks we're here, and it's like there is no length variable. So how we can resolve that is all we need to do is bring the length variable before the sketch feature, which you can just click and drag in the tree here, or bring the sketch feature after the variable. You can go in either direction. You can reorder things. And that goes for any feature. That goes for any feature in 2D and in 3D that you can change the order of things. It's really important to understand that sometimes sketches will be dependent upon each other. And if you make a sketch dependent on another sketch, that means that henceforward, forever forward, that second sketch you made will always have to come after that first one. So just be aware of that. Most of the time, you won't have to reorder things. That's a pretty advanced technique. But do be aware that when you are reordering things, that you have to consider what those things are referencing. All right, cool. Back to the presentation. Generally, you want to use variables for commonly changed values of things very early in the design, or you want them to be numbers that need to be calculated regularly. You can actually do math in the dimensions of Onshape and other CAD programs. So like, even though this is the value of length, maybe I want it to be length divided by 2 inches. Maybe just 2. So now, instead of that value being 25, that length is actually 12.5. So to do CAD, you don't really even need to be good at math. You just need to write what the expression is. And it'll do the math for you. It has sine and cosine functions. It has square roots. It has to the power of. It's got all kinds of different things in it that you can do math straight in CAD without needing to do it like down on a piece of paper. And this is super useful if you're trying to change the size of something and you don't want to have to do that math over every single time. So this is like parametric math. It's kind of like an Excel sheet, but with CAD, where it'll automatically do the math for you the first time that you create it. And henceforward. Now, do keep in mind when you delete that dimension, its equation goes away too. So be careful with that. And then what else? Oh yeah, the variable names are, like I said, the pound sign and then the name of the variable. You can't have spaces, and I think it needs to start with a letter and not a number. There's a few little rules to that, just like kind of like in programming. All right, any questions? All right, cool. Now we're going to jump into an exercise. So I would like everybody to get into CAD, and we are going to sketch a steering wheel. I don't really care what kind of steering wheel. I just want it to be somewhat looking like a steering wheel. It could be a steering wheel for feet. It could be a ship's steering wheel like I have here. It could be like a race car steering wheel. It could be your bike's handlebars or something. It could be whatever. But I would like you all to start drawing a steering wheel. And I have a few just notes here that I would like you to consider as you're drawing this. Symmetry. Think of the symmetry in the wheel that you're drawing. All of the ones that I have listed here have symmetry, some of different types than the other. Some have patterns. You usually, if you're drawing a symmetric wheel, you usually don't need to draw both sides. But you don't have to draw some symmetric wheel. You can draw an asymmetric wheel where it's very different on one side versus on the other. I want you to think about how you're going to create depth in the wheel. So although your first 2D sketch might be from the front, kind of as you're looking at the wheel right now, maybe think about what it would look like if you were to cut it in half and look from the side, like a cross section. How would that profile look? And I also want you to think about actual useful size of the wheel. And if you want to get like bonus points, you can use a variable to define the wheel, the actual overall diameter of the wheel, or some other feature of the wheel. There's no correct design here. There's no that's not a wheel. It could be whatever. It just needs to be something that is a closed shape that you can then extrude or revolve or something along those lines, which we'll talk about later. And I'll give you some feedback on what you can and can't extrude. And you can have it look really cool. You can have it just be a very simple, basic steering wheel. Again, there's no wrong answer. And if you'd like to just start messing around with the 3D features, you're more than welcome to. Extrude and revolve are going to be 90+% of what is used in robotics, with a few exceptions. But have at it. I'm going to give you guys like 20 minutes. We'll gather back together at like 8 to show everybody our wheels and to go through them. And if you have any questions or concerns or issues, just let me know. And then we're going to talk about version control after that. So I might go and sketch a wheel as an exercise too. You guys don't have to watch, but I'm going to go mess around with the wheel. You can also do this in a new part studio if you like, and you can rename that specific part studio steering wheel or something along those lines. It's generally good practice to name your documents and to name your tabs so that we know what they are, especially when we're collaborating as a team on things. If you just have Part Studio 1 through 20 and you have no idea what any of those part studios are, it's going to be really difficult for your team members to figure out what you're thinking and what you're making. So the first thing you're going to need to do is create a sketch on one of the planes. You can choose whatever plane you like. I'm going to personally choose the top plane here. And I'm going to click the N key to go normal to that plane when I'm sketching. Now, steering wheels are a lot of the times round. So I'm going to start with something round. But I'm going to make something symmetric. I'm going to draw a line from top to bottom and then trim half it off. Let's see. Roll back. And I don't know what the size of the steering wheel is. Maybe I need to look that up. Maybe that's a number that I need to look up. you want your wheel to be able to proportionally scale, or anything to be proportionally scale, you'll have to do multipliers or dividers by whatever variable you use. So I made a variable called diameter, and I would like my wheel to stay proportional as it gets larger and smaller, so that the dimensions they automatically change. And I'm doing that by referencing all of my dimensions relative to diameter. So I have my wheel, like the hand grip size is my diameter divided by 10. The radius is the diameter over 2. This inner web, I'm going to make that like diameter divided by 8 or something. I don't know. Tangent. Be sure to use your constraints effectively. Think about your lines of symmetry and how you can minimize the total number of lines you need to sketch. And as I said, feel free to bring it into the 3D. I'm going to actually start a different place. Make sure your sketches are fully constrained, which means all black lines. Every single line should be black in the whole thing. I'm going to use a revolve first, actually. And then I'm going to cut away everything after the revolve. Maybe I want to change that. Yeah. All right, I kind of messed that up. Cool. All right. I drew up a little thing that's still got some issues, but it looks kind of cool. Would anybody like to share their design? All right, I'm gonna start picking on people. Did anybody raise their hand? Sorry, I missed the thing. All right, Addie, would you like to share if you have something?
I really don't. I don't get this. Like, having trouble.
Okay, well then, can I see what you've got so far? Maybe we can walk you through that, and that's probably going to be really helpful for other people too. I'll stop sharing for a minute.
I was trying to get it to like move out, but like this one does, and this one doesn't.
Okay. So that means that you have constraints on one and not constraints on the other. Okay.
Oh,
So those are your constraints right there. So maybe you want to delete that one. Give that a try. And when you say move out, can you describe what you mean exactly?
like, hold on. I'm trying to like now it's combined.
Yep. So when you moved it just like that, you
Oh,
add whenever you see wait, stop there for a second. Do you see how when you click and drag something, like grab the center, you click and drag that and bring it towards the center? Do you see how that little coincident constraint shows up?
yo, that's a lot.
That means that when you let go of the mouse key, it's going to add that constraint.
Oh, okay.
Does that make sense?
Yeah.
It's a little bit confusing for sure. But so is your wheel going to be symmetric? Do you think
Yeah.
it will? All right, cool. Then I'm going to ask you to delete one side or the other of your wheel.
How do I do that?
Wait, undo what you just did for a second. Control Z. The Control Z does work. Click on the circle, not quite there. Click on the line to your right. Let's delete the right side, okay? So click on the curved line of the inside circle. Yep. Now you have, yep, exactly. There you go. Now click delete, the delete key. There you go. That's all it takes to delete. And do the same thing for the one on the right. Actually, we're going to do something a little bit different on the right because that's one big circle. Do you see that?
Yeah.
When you go over the line, it's one big circle, right?
Mm-hmm.
So instead, we're going to use the trim tool. I talked about that last meeting, but this will be a good instance to use the trim tool. Yep, you've got it. It's a little bit intuitive. And if you click the line, there you go. You've trimmed that right side of the circle. And now if you click escape key, you'll no longer be using the trim tool.
Okay.
Does that make sense?
Yeah.
Also, click the N key one time because you're not quite normal to your sketch. There you go. See how you're dead straight onto it now?
Yeah.
Perfect. All right, so you've got an outer circle and an inner circle. That's a great start. That's an absolutely fantastic start. Now, yeah, grab that and move it down a little bit or move it to where you'd like to have it. Okay, cool. Do you think your wheel's going to have like spokes or something?
Yeah, like maybe one here, one here. So when
Okay.
it's symmetrical, it's gonna be like one across and then one down here.
Okay, perfect. How big do you want your hand grippy part to be?
I don't know, maybe 3 inches.
3 inches. That's a pretty big grip, but maybe we're drawing maybe we're making like a trucker's like a monster truck steering wheel. Or somebody with really big hands. Like this is gonna be Shaq's steering wheel, right? Where he's got like giant hands and the little tiny ones are too small for him.
Okay.
So what I'm gonna suggest is I'm gonna ask you to put a dimension on your wheel. Because right now you don't have any dimensions. You have no idea how big this thing is. So I would start generally with the outside dimension. There you go. So click there and click one more time. Good. And now you can edit that number. So 4 inches is only like, that's a 4-inch diameter. That's about this big. Is that as big of a steering wheel as you want? Oh, you can't see my screen. Sorry.
Uh, let's make this like 10-inch.
I think that sounds better. So it's a 20-inch steering wheel. It's a pretty big steering wheel. Remember, that's a radius. Do you see how it has the R there? That means that
Yeah.
it's a radius. And then you said you wanted your handle grip to be 3 inches?
Yeah.
Cool. All right, so click there. And then click the outer one, the outer ring. Nope. Wait. Stop for a second. What you're dimensioning is that inner radius, to be clear. You're not dimensioning the distance between the outer one and the inner one.
Oh.
So if you click escape, And if you click on that dimension, not on the line, yeah, there you go. You can just undo, or you can click on the dimension, just delete the dimension.
Okay.
So now do dimension again and click on the inner radius.
Like here?
No, like the line itself. That's the outer radius. You can click that first, and now click the inner radius. Yep, that one. Now you can dimension. Do you see how that's doing the distance between the two?
Yeah.
Cool. Now let's do a little experiment. If you change 10, do you think 3 is going to change?
Yes.
It will?
Yeah.
All right, give it a try.
Oh, it doesn't.
It doesn't change because you're telling it, you're constraining it to be 3 inches. Does that make sense?
Yeah.
All right, was that helpful?
Yeah.
All right,
That makes sense.
all right, perfect. I'm going to let you go and try to draw your spoke next. And you can change your dimensions. You can make it however big or small you want, and then try to make that spoke thing that you were talking about. All right?
Okay.
Cool.
Should I stop sharing?
Yes, please. And then we're going to have somebody else share. All right, I'm going to pick on, let's see, Grace. How is Grace?
I don't really know what I'm doing.
That's okay. That's what we're all here for. Do you want to know what you're doing?
Preferably, yes.
All right, good. Then you're in the right place. I will do my best to help you try to learn what you're doing. So could you share your screen and show us what you've got so far, if you want?
Yeah.
Ooh, I see construction geometry. That's promising. That's exciting. Grace, this is already looking awesome. So are you trying to make like the ship's wheel?
Yeah.
Perfect. One thing to make note about the ship's wheel. What does it have? In terms of like consistency, or are there multiples of one thing?
It's like it's symmetrical.
Good. Oh, it could be symmetrical. So you're saying yours is going to be symmetrical?
Yeah.
Okay. How I'm going to set up yours, how I think you should set up yours at least, is create a variable for how many spokes you want to have. Okay.
Yeah.
So yeah, you're going to create and you got to make sure this variable happens before your sketch, which you'll do that later, but just call this, you can't do it when you're editing it. So just call it spokes and make sure it's not a length, make sure it's a number. That's going to be important. It's important to distinguish like what units you're using. A number doesn't have any units, so we want to use a number. And just put in a number for now. The one that was in the drawing, or the one that you had, has like 6, it looks like, right?
Yeah.
Cool. So let's do 6. Good. You ordered it before the sketch. Fantastic. All right. Now let's start with, in your first sketch, I want you to just make like the ring where you want the spokes attached to. Okay. We won't make the spokes just yet. So you can actually remove all those if you'd like. Yeah.
All right.
And so just if you want to make it a solid core one, just dimension that solid core so that it's constrained.
Oh, I was gonna try to make it a ring, but I don't know how to do that.
I'll show you how to do that. Click the dimension button. You're going to first dimension this one. So how big do you want this ship steering wheel to be? Like giant, like a big ship?
Like a foot, I guess, across, a foot diameter.
Okay, that's a pretty small one. It's like this. All right, perfect. And then to make a ring, you actually have a few options to make a ring. You can either do what Addie did, which is she made a second circle that was smaller, or if you want to try something new and unique, do you want to try something new and unique?
Sure.
You can use the offset function, which will just take whatever geometry you have and offset it either inwards or outwards. And the offset function is, if you scroll up, do you see where the scissors are?
Yeah.
It's right next to the scissors. Yep. And it is the O key. So I want you to click that line. And then do you see the little arrow key that exists there?
Yeah, this.
Let's offset to the inside instead. So if you click that, yep, you can click and drag it, and you can adjust the size of your ring. And you can change this value later. So you can create it wherever, hit enter. And now you can adjust the dimension. So make the number whatever the heck you want.
Okay.
And we can change it later. We can change all of this later. Okay.
Okay.
All right. Perfect. So that looks great. That's a fantastic ring. It looks like it's going to be a really good ship steering wheel. So I want you to finish this sketch for now. Just click the checkbox. Okay, cool. And I'm going to have you bring this into 2D or into 3D. I mean, so you're going to use the extrude function.
That's okay, right?
Yep. So just use that, and just select the outer ring. So that you're in the selection box right now for what you want to extrude. That's what's blue highlighted there. Yep. So just click the outer ring. There you go. And now if you rotate around, you'll see that it's got some thickness to it now. And if that looks like reasonable thickness to you for a ship steering wheel, then you can click the green checkbox or adjust the number. And now we're going to make a single spoke. And you can make it either the internal or the external ones. It doesn't matter to me. So I would start a new sketch. Do you want the spokes to be round? We're going to do something interesting if you want the spokes to be round.
Yeah.
All right, cool. You're going to make a new sketch on the right or front plane. It doesn't matter which. Cool. Click N because you're not normal to that plane right now. The N key. There you go. Perfect. Now I want you to imagine you take one of those spokes and you cut it right down its center line. And kind of what it would look like. Okay.
Semicircle.
A semicircle, but do you want the spokes to have any length to them?
Yeah.
If it's just a semicircle, it'll just be like a nub. But do you want it to be longer than a nub?
Yeah.
All right, cool. So what I suggest is drawing a line that's going to be the center of your spoke. That's going to go outwards, right, in your case.
Mm-hmm.
Draw a single line that goes from
like
the center.
This one?
Yep, exactly. And you can make that whatever length you want. And then that's going to be the center line of your spoke. So you're going to rotate something around here. You're going to create a revolve feature, okay? So leave that as it is, and then, or you could dimension it, sure, that's perfect. If you would like, put a length on it. Perfect. And now do you see how that thing became off of the edge?
Yeah.
You're going to want to constrain that so that it is on the edge. And you have a round surface there, so you can't really constrain a point to a round surface very well, right?
Yeah.
But you did make a sketch that has a circle that you could potentially put a point on. So this is getting a little bit more complicated, but I'm going to walk you through it. I'm going to show you my rationale. I would finish this sketch as it is and leave it be, and we'll come back to it. I would go back into sketch one. We're going to be time travelers for a second. We're going to go back in time. All you need to do is double click to edit sketches. Go back and go normal to sketch one. Just click the N key. And you're going to make a point, which is, do you see the little A up in the top? Little text thing?
Yeah.
Point is right next to that. So go to the left. There you go. So click that. And then create a point very completely horizontal from the center line on the outside of the circle. There you go. Click. Perfect. All right, you've got your point. So now exit the sketch. And what you've done there is you've created a point that you can reference in that other sketch now. And this is what I mean by using other sketches to generate reference points for you. So do you see how your sketch one isn't visible right now over in the left?
Yeah.
Yeah, click that. There you go. Now you can see that sketch. So zoom in a little bit. And now you can draw a line from that point up to the top of your part. This is going to be a construction geometry line.
Like that?
Yep, that works. And then you're going to make beautiful. You can also use the Q key. And then you're going to make that line vertical. So click on that line and make it vertical. And then here's the tricky part. You want to make this centered on the wheel, I'm assuming, right?
Yeah.
Cool. So what I would do in this scenario is I would make one more line exactly how you did that one, except going up to the top. So it's going to be construction line right from there all the way to the top. Yep, it's perfect. And then you can just hit escape. Oh, did you auto dimension that?
Maybe.
That was cool. I've never seen that. You pressed some button that auto dimensioned it, which is cool. So delete the dimension for now. We're actually not going to use that dimension. Click the top point. Yep. Yep. You're on the right track. Click the top surface of the, yep. And make those two coincident. There you go. Make sure that top line is construction geometry. I think it's not right now. There you go. And now to make that thing centered, which constraint do you think you're going to use?
Equal?
Yes, very good. So you're going to make the top line equal to the bottom line. And now it will be centered no matter what the height of the wheel is, right? If you put a dimension there for the height, every time you change the thickness of your ring, it wouldn't be centered. You'd have to re-go and re-edit that value. But because you constrained it such a way, it will now always be centered on the ring. Make sense?
Yeah.
All right, cool. Now you're going to draw the profile. Like if you were to cross your guy and cut your post in half, your peg, draw that profile or half of it and see what you can come up with. It could be interesting. It could be a weird shape. We can always edit it later. If you want to make it really simple for now, just do a curve at the end and then just do a line back to the base.
Like
I think that one will work. So it's 3 points. You're going to need to click in 3 different places. One. Not there. If you do it there, your piece isn't going to have any thickness at the bottom because remember we're revolving around this base point, right?
Yeah.
So you're on the right tool if you use the 3-point curve, but just don't bring it back to the line. Just leave it out in space somewhere. Yeah, that's good.
Whoa.
And then that should be good right there. This is a trick. We're gonna make sure that this circle comes to a perfect radius at the edge. Do you see the center point of that circle? It's at the bottom. It's kind of by the 3. Yep. You're still actually creating a 3-point circle. There you go. So click on that dot, and then click on your center line, or bring it up to your center line. That's fine. And make them. There you go. Perfect. Now your circle at the end. Your peg will be perfectly rounded over. There won't be a point or anything at the end. Now make a line from the end, the kind of floating end that's not anywhere at the moment, just a straight line for now. Back to, yep, you got it, right to there. And then make one more line that goes from there to the bottom. Yep. Perfect. Do you see how it went dark right there?
Yeah.
That means you just created an enclosed shape. Okay? That's awesome. That's really good. We're going to leave your sketch right here. And we're going to see what this turns into before you make it the way that you want to make it. Okay?
Okay.
So click the green checkbox. And we're going to use the Revolve tool. And I'm introducing you guys to this stuff a little bit early. We'll go more into detail about how these tools work, but I'm going to walk Grace through this. So use the Revolve tool. And you're going to click the profile that you just created. Yep. And then you're going to select the axis that you want to rotate this thing around. So which axis is that? You have to click. Do you see the red box on the left? You have to click the red box first. There you go. Good. That's the right axis. And look at that. You want to do a new, by the way. So click new for now. We'll add it later. And rotate around, and you can now see your part. You can see your shape. Ah, that's pretty cool. Sweet. Click the checkbox on that. And then you can do a circular pattern if you wanted to, which the pattern key is right next to the mirror button up at the top. Left, left, left. It's a rectangular pattern right now, but there's an arrow next to it. Left, left. There it is. There. Oh, you passed it. Next one.
Okay.
That's a linear pattern. You want to do a circular pattern. There you go. And so now you want to choose the thing that you want to pattern, which is that guy. Yep. Then you want to choose the axis of your pattern. You have to click on the red box first. And what's that? Not quite.
Like.
You're close. Yep. I think that might work. There you go. And now do you see where it says instance count? Remember how we created that variable earlier? I want you to type in the pound sign and then spokes. Then click the green checkbox. And now, anytime that you edit that spokes variable, it'll change that. So open the spokes variable and change it. Change it, I don't know, 8 or something, 20, whatever you want. Now you have 8 spokes, evenly spaced, automatically. Cool, good stuff. All right, Grace, next for you, I want you to make your spokes whatever shape you want them to be, and also make the spokes the same part as the inner ring, because right now you'll see they're separate parts. You have 9 separate parts. And that's going to be a little tricky. You're going to have to change your one sketch a little. All right. Who would like to share next? Thank you, Grace. Good work.
Thank you.
Let's see. Who is Mr. Pingu? Is that like an anime character or something? Or is it your actual name?
No, it's like Pingu the penguin.
I don't know
Sorry.
who Pingu. Oh, I do know who Pingu is. Got it. All right. Who am I speaking to?
I'm a student at Archbishop Wood.
Oh, perfect. Nice to meet you. What's your name?
Brent.
Brent, did you say?
Yeah.
Perfect. Nice to meet you, Brent. Were you able to follow along with us or no?
Kind of.
Okay. Did you create an Onshape account?
I did, yeah.
All right, perfect. Do you have something you'd like to share? If not, you don't have to. I'm not going to make you do anything.
I did it on a different device. Can I paste the link?
I think so. Yeah, you're going to have to give like sharing access to the document, but if you have the link, sure. And then I could share on my screen.
Okay, hold on. Oh wait, so it was okay. I think I should be in the chat.
It is. So I'm going to come in here and I'm going to share my screen. Let's see. Here it comes. It's going to take just a minute. Now, I'm not going to be able to edit anything, but I'm going to be able to view it. Awesome. All right. So you made a wheel that has the words Ford in it. Beautiful. This is absolutely fantastic. I'm assuming you're a fan of Fords.
No, I just added a
It's
logo.
just a wild guess. I didn't have any context clues or anything. Okay, all right, cool, sweet. I love it. Looks absolutely fantastic. So you, interestingly enough, you did this all with one sketch. You created both of these parts because you actually have two separate parts here, which is cool. So you did it with one sketch and one single extrude feature. So this is a good example of it on shape. You can make multiple parts with one, like a geometry pattern on the inside, or like a used an octagon or whatever, nonagon or something for this inside shape, right? I come into sketch. Yeah, so you've got a whatever 12 sides is a gon. And I see you're using construction geometry, which is good, and you're dimensioning things perfect. Now, how might you go about making? First of all, do you want to make your outer wheel rounded, like so that somebody could grab it? Is that something that's desirable to you?
Yeah, sure.
Okay. Do you have any ideas about how you might do that, or no?
Not at the moment.
Okay. You have a few different options. You can use a tool called Fillet, which will round all of these corners, and you just need to select all these four corners of this piece. And it wouldn't exactly be like a straight up torus shape. It'd have some height to it because your part is taller than it is thick. But if it were the same height as it is wide or thick, then you'd be able to make a perfect torus out of just the fillet feature. So that's one way to do it. Another way to do it is, did you see the revolve feature that I had Grace do earlier?
Yeah, I did.
So you could draw a circle at the right radius from the center on either the, what is that, the top plane, your top plane, or your right plane. So you could draw it like this. Up here, you draw a circle like somewhere in this vicinity. Or you could draw a circle somewhere in this vicinity from the right plane, okay? And then you can use a revolve that uses an intersect. And what that does is it will only keep the material that intersects with your new revolve. It'll subtract everything else away. And now you're left with a ring that's round instead of a ring that's kind of like a squared off ring or like a cylinder. Does that make some amount of sense? A little bit of sense?
Some amount, yeah.
All right. I can walk you through this in a document that I've opened, if that would be helpful. You think that'd be helpful? I could do it real quick. All right, I'm going to do it real quick for you. I'm going to create a new sketch on the top plane. And I'm going to make kind of what you made, but just simpler. Because I'm going to do it as quickly as I can. I'm going to make a circle, another circle. I'm going to put a dimension on them. That's 1.5 inches. I'm going to make the outer diameter like 13 inches. And why didn't that center? For whatever reason, the circle didn't center. So I'm going to bring it to the center so they're both concentric. I could have also clicked on both circles and done the concentric feature. I'm going to extrude this, and I'm going to extrude it, I don't know, an inch or 1 point, what did I say, 1.25. And now if I drew a sketch on the front plane, that is a circle that's like this. I'm going to make one little difference. I'm going to make this thing, instead of one direction, I'm going to make it symmetric between both sides. So it's coming out of the top plane from the top and the bottom. So just to show everybody the difference. When I don't click the symmetric button, it only extrudes from one direction. When I use the symmetric button on an extrude, it splits the difference between the two and it goes up and down. So I'll do that. And I'm going to edit this sketch so that I have a line from here to here. That's construction geometry, and a line from here to here. Reference. Show you why I'm doing that in a second. That way, when I edit this sketch and I show my other sketch, I have a point that I can reference. I can put this right in the center of that line and then click the circle and make it part of that. Now, clearly, I need to adjust the thickness a little bit. I made it 1.5 inches, so I'm going to go back and change my height to 1.5. I know I'm moving very fast. I apologize. I'm just trying to get through some of these demonstrations. And I'm going to use this sketch and something called, I'll do a make connector. Something called a make connector on the top that is just a localized coordinate axes. It's just an X, Y, and Z. And I'm going to do a revolve of that sketch we just made, just that circle. And it's going to be about that brand new make connector that we just made. And instead of add, it's going to be intersect. So it's only going to leave us with the material that is intersecting. And you can see exactly what this does. It takes this kind of squared off ring and it subtracts all the corners of it. It only leaves the round part in the center, like you see. And that'll make a perfect torus. Does that help give a good example of how to use the like subtracting tools that exist in Onshape here and in other CAD programs?
Yeah.
I know I was moving very fast. We will have more time to go and practice this stuff. I'm trying to get through the basics. The first like 2-3 weeks of classes are going to be throwing all of the features at you, and then the rest of the class is going to be you guys learning applying those features for the most part. And you can do this stuff all on your own as well. Perfect. All right. Thank you very much. That looked fantastic. Like you did a great job on your little one here. Absolutely amazing work. So see if you can apply what I just talked about to yours if you wanted to make that outer ring like a torus shape. Thank you, Brent. All right. Would anybody else like to share in the meantime? All right. Keep on working on your wheel if you'd like. This is mostly just an exercise for all of you to start getting familiar with these sketching tools and when and how to use constraints. But I'm going to move on. Emily, did you have something you want to say?
No, I'm okay.
All right, cool. So I'm going to move on and we're going to talk about version control a little bit. So this picture doesn't make a lot of sense right now, but I'm going to walk you through it. Version control is a way for people that are making things, especially on computers, to make changes over time between multiple people and to be able to track the changes that they make so that if they do make a glaring, huge, horrible mistake, they can always go back to the previous version that they had. So how I describe version control is imagine you have a big pile of Legos, okay? And all of us here in the class, we all have access to the same big pile of Legos, all right? But we want to make something collectively together with those Legos. But we don't all want to work on the same thing at the same time. Maybe one person wants to make one part of the Lego set and one person wants to make another set. Well, with version control, we can do that all concurrently at the same time. So if I go and take this pile of Legos, if I pick it up from the table where it's accessible to everybody and bring it over to my own personal table, imagine that existing pile of Legos doesn't change at all. It still exists on the original table that everybody has access to. So I basically kind of clone the pile. I make a copy of everything that's in that pile exactly as it is and take it over to my workspace. And now, say in my workspace, I go and I make a car out of the pile of Legos. All right. But I still have some extra Legos left over. But now I have my own personal car, and the other pile is still just a pile of Legos. Well, if I wanted to, I could then take my car and the remaining Legos and bring them back to the pile. And when I take my version and put it back on the pile, it updates itself and now has both the car and the pile, the extra pile. So I've committed the changes that I made to the pile of Legos, to the local to the shared version of the pile. So now anybody can go and pick up the pile and my car and make changes to that they would like to see. Now imagine before I committed my changes, before I put the car or the pile back down, imagine that somebody else took the pile and made a house. They took the house and they made a nice little simple house, and then they saved their changes on their own local machine without committing it. So they didn't send it back to the main pile of Legos. They just kept it there and they walked away from it for a while. And then they came back to it later, that same person, and they added a bunch of features. Like in this case, they added a garage and they added a basketball hoop and they added some gables with some windows and a little satellite dish and so on and so forth. So they added those onto this newest version, and then they take that version, and after I've created my car now and this house has been updated, they commit that version to the main repository, to the main pile of Legos. Now we have a car and a house in the same space, in the pile of Legos that anybody can now access as well. So now anybody else that goes and picks up the basic, like the shared pile, will already have a car and they'll already have a house. That's at a high level how version control works. There's a lot more stuff that goes on, but I hope that helps explain it a little bit more, kind of like at a basic level. This is how I see it and how it makes sense to me. When I've learned it, I've just read, like if you go online and you just read about version control, they'll start talking about like code, and they'll name these different things that you have to do, and things that don't make sense, that you don't understand. This is a way that I found to break it down into things that people know and that they're familiar with, and just to make more sense of the idea. So does anybody have any questions about version control? And it's okay if it doesn't make sense yet. All right, sounds good. Well, I'm going to move on. So version control in Onshape is built right into the platform. So I'm going to pull it open here real quick. You'll see over here on the left side of the page, you've got this versions in history, and then you've got this create version. So if I open up versions in history, you'll see I have the very start where all I did was create the file and nothing existed. And that's what this version is. And I can actually click on that and view that version if I wanted to. But there's nothing there, so it doesn't really matter. And now each version will show you exactly every single thing that changed. It shows every number that you change. It shows every time you edited or created a sketch. It shows every time that you move the rollback bar back and forth, which is I call the time travel bar. It's this guy when you go up and down with it. It shows when you rename something, or it literally shows every time you edit anything. But now that's my live active version. If I said, hey, I really like how this looks right now, and I want to save this version of it so that if I add something to it, I don't screw it up. What I could do is hit this little create version, and it's kind of, think of it as like a save. You're saving this document in time as it is. So I'm going to call it V1, and I'm just going to say first version with first version period created a Taurus. I don't know if that's how you spell Taurus. And I'm going to click create version, and you'll notice that changed this little graph over here. I've saved that version. Now that version is set. I can't make any more changes specifically to that version. I can go back to it, but I can't make any changes to it. And you can also view that version. So if I click on this, it'll show me exactly what that version is. So like, let's say in this, I'm going back to the main branch. Let's say I just took this and extruded it up by 1 inch. Sure. Now, if I go back to the V1, it's not going to have that because I didn't create that in V1. I only created this torus in V1. But if I go back to main, now I still have that new extrusion feature that I created. It still exists. So version control, it can just be a linear step of the progress of your project. You can also do crazy stuff like branches. So if I wanted to add a doohickey to my part here, and I wasn't sure if I wanted it to be in the part in the future, I could create a branch and add the doohickey there. But maybe I don't like the doohickey and I just ignore it. Well, then I just have a branch that goes nowhere. But maybe I make the doohickey and it's really cool. It's really useful. It's a good feature. I can push it back into the main portion of it. And this would kind of be like when somebody's creating a car and somebody's creating a house, and then we bring them back together into the main version of the file. So you can do that in Onshape. We're probably not going to do too much of the branching, but we are going to be using the version control in this class. Any questions? All right, cool. In fact, everybody right now create a version of your document as it stands, just for practice. Even if it's not finished, even if there's like, even if it's a mess and you have errors and red things, just make a version. All right. And then configurations. We're going to talk about configurations for a minute. Configurations are when you have a part that has extremely similar features to another part, but there's a million parts that are like it with slightly different dimensions, or maybe it has this thing and this other one doesn't. A configuration is a really, really good way to go about that. We're probably not going to use configurations a whole lot in this course, except for using the fastener system in Onshape. So in Onshape, it has a built-in library of fasteners. So if I go into this assembly document, and we'll do more in assemblies, I'm just going to show you what configurations mean. I'm going to click this insert, and I'm going to go to standard content, and I'm just going to do a bolt, the socket head bolt. So when I click this socket head bolt, I have a bunch of options here that I can edit. I can choose what kind of socket head bolt or screw that I want to use. And right now I have a shoulder bolt selected, which is this kind of thing right here. But maybe I just want a button head bolt instead. This is a different configuration of the bolt. Or maybe I want a countersunk bolt instead. It's a different configuration. And let's say in this countersunk bolt, I want it, instead of 1/4-20, I want it to be 1032. Just a smaller size, same kind of bolt, but it's just the next size down. And let's say instead of 1.5 inches, I want it to be 2 inches. It's the same part. I'm just changing some dimensions on it, and we literally have millions of options based on these little drop downs here. And then you can actually choose how long you want the threads to be as well, if you want some length of like solid shoulder versus all threads. And you can even choose the material, and there's 20 choices of material even here. So I'm going to insert this guy just to give you an example. So here's my countersunk screw that I just created. But then I'm going to choose another one that's 0.75, and I'm going to insert that too. And then I'm going to do another one that's 3 inches, and that one's going to be 1/4-20 instead, so it's a different size. So this is how configurations can be used. You can create hundreds of thousands of different parts really quickly just by changing the basic dimensions and information about them. Like I said, we're not going to be creating configurations generally too much in this class, but we will be using things that do use configurations. And fasteners are a good example of that. Bolts are a really, really good example of that. Cool. Any questions? All right, cool. moving on. We're going to talk about torque a little bit today. This is one of my favorite subjects. And for those of you who've taken physics, you probably already know some bit about this. But a conversation about torque is important to have in the conversation that we're going to have about shafts, hubs, and bearings. I'm going to jump into this presentation. And again, these presentations are by Team 3005, who is the RoboChargers. They provided these publicly for people to use. They're really fantastic. They're likely going to make changes and updates to them as time goes on. So today we're going to talk about torque and moments. So torque is a twisting or rotational force. Some examples that they list here are the force required to unscrew a bottle cap, or the force a motor applies to rotate a shaft, or what you use to tighten a bolt. A good example that I like to use is if you hold a shopping bag. If you hold a shopping bag and you have your arm like dead straight out, is it more difficult that way, or is it more difficult when your arm's straight down? Well, it's obviously much more difficult to hold the groceries straight out because you're applying the same amount of force. The groceries didn't change weight. They're still like 5 or 10 pounds or so. But what did change is the lever arm length. When your arm's straight out, it's the length from the pivot point, which is your shoulder, to your hand. That's much further than when your shoulder and your arm are directly in line. And you don't need to hold them up with your shoulder. So torque is measured in, let's see. So there's the symbol for torque, which is this tau, which is the Greek letter T, basically. It's measured with a unit that uses multiple. It's known as a compound unit. It has multiple basal units. So instead of like just feet or inches or seconds or pounds, it uses 2 different units. And this one is a distance and a force. And torque is a force applied at a distance. So the units that are used are things like foot-pounds, Newton meters, inch ounces. You'll notice they swap kind of back and forth sometimes, whether the force is first or the distance is first. It really doesn't matter which order they're in. What does matter is which units are used. So, for example, a foot-pound is 1 pound of force being applied at a foot from the pivot point. And we're just going to give an example here. So a moment and a moment arm is the product of a physical quantity, force and mass, and a distance. So you can see here that torque is the force applied between the center point and the end of the arm. And the moment arm is the distance between where the force is applied and the pivot point. Specifically, a moment arm is the distance between the joint's axis of rotation and the line of the force acting on it. So it's a good little explanation right there. And the equation for it, it's just straight up, it's an easy multiplication. It's the force that's applied times the distance that's applied from the center. That's all. I'm not going to go through these examples, the number examples, but I do want to talk about angled forces. So when you apply the force on a torque arm at an angle, the only thing that matters to that force, to that torque, is the perpendicular amount of force. And you can learn this. You can apply, cosine or sine if you're familiar with trigonometry to determine these values. But essentially, if this horizontal force here is at a 45-degree angle and it's like 1.3 something or 1.2 something, If you apply it at a 90-degree angle, which is like this direction, then it will be closer to 1 pound, 1 unit of force. And that's the unit that you want to use to actually calculate torque. Because you can imagine if the force is applied directly in line with the arm, whether it's like towards the center or away from the center, it's not going to cause a rotation. It's just a force directly towards the center, towards the rotating point. But as you rotate the force at some angle to the pivot point, it becomes a torque on the pivot point. So example is if you push your fingers just directly together like this, right? You're not causing any of the fingers to rotate, you're just pushing them together. Now, as I rotate this finger around, it now is causing this finger to rotate about my joint. And so these are the equations that you use, and it depends on where you're reading the angle from, but generally speaking, you use the sine of the angle to determine the force that's applied, and that will give you your actual torque. And I'm not going to go through these numbered examples, but torque is really, really important when you're trying to figure out how much you want to lift something with an arm, or how fast you want to be able to shoot a ball, or how strongly you want to be able to grab a ball when you're intaking, or like how much force you need to open and retract your intake arms, whether you're using cylinders or whether you're using like a motor or something. Yeah, so that's torque. Does anybody have any questions about that? Cool. Again, for those of you that have taken physics, this is probably all old news to you. But it's just a quick overview to try to get people familiar with the idea of torque. So I'm going to move on to conversation about shafts, hubs, and bearings. And these are all components that are very, very, very commonly used in FIRST. In fact, I can't think of a single robot in FIRST that I've ever seen that did not have a shaft on it. And most contain bearings of some kind as well. And most also contain hubs. So we're going to start with shafts. A shaft is a rotating bar that supports or transmits torque to another part of the machine. So recall, we were just talking about torque. The important part about a shaft is that it is the thing that transmits the torque from one part of the shaft to another part of the shaft. It typically rotates along with whatever the shaft is driving, as long as you've designed it well. It transmits the torque to or from the driving component. So it could be transmitting, it could be the shaft of the motor transmitting torque to the gear that is attached to another gear that is attached to another shaft that is transmitting it to a wheel. That's a very, very common configuration for torque transfer. And it usually has a locking feature that engages with another face or feature on the driven component. So if you imagine, if you just had a round shaft and a round hole, if you didn't have any kind of interference between the two, the round shaft would just rotate in the round hole and you wouldn't transfer any torque. So that's why in FRC you commonly see things like hex shafts or keys in a shaft. A key and a hex shaft are ways for the torque in the shaft to be transmitted. A good thing to note is a live axle versus a dead axle. A lot of times they're confused with each other or they're not necessarily understood the difference between. But a live axle is when the shaft is transmitting the torque to the rotating object, to the wheel or to the flywheel or to the arm. And that's known as a live axle. So that's when the shaft rotates with the object and it is actually transferring the torque from the driven thing to the driving thing, or vice versa, from the driving thing to the driven thing. And a dead axle or dead shaft is one where the shaft actually does not rotate with the rotating object. The shaft is only there as a support. And it typically doesn't rotate. They can rotate. You can have a dead shaft or a dead axle that does rotate, but typically they're fixed. And the shaft is only there as a means of support for the rotating object. A common example of a dead shaft is shoulder bolts, like I was talking about before. They don't usually rotate with the object. They're usually just fixed, attached to something, and then the bearing or the object that they're rotating about is rotating about them, around them. In FRC, and in FTC, we commonly use hex shafts. And we use hex shafts so that we can easily use different parts between robots and between different designs. It's kind of like a universal design that we don't need to apply any extra feature to do torque transfer. But it also is just very simple to use, and it allows you to kind of rotate your things and mount them very easily. And a hex will obviously transfer torque, whereas a round shaft in a round hole would not transfer torque normally. The most common shaft type in FRC for sure, and there's different types. There's regular solid hex, and there's also thunder hex, which is what you see here, where it has some of the material cut away to be able to use a specific diameter bearing, as well as to save a little bit of weight. And it's similar in use to a square shaft, but instead of 4 sides, it has 6 sides. And then there's keyed shafts. So keyed shafts look like this, and they usually have a mating keyed hub. We'll talk about hubs in a little bit. And the key is a little piece of material. They usually look like this, and they're usually square in profile, so they have the same depth as they have width. And the key sits in the shaft that has a little notch cut into it to fit the key, and it fits into the hub or the mating object. And the key is the thing that then applies the torque. So this is a round shaft, but because it has a key in it, it allows you to rotate the shaft with the hub or with the object. Reasons that this are used is they're very easy to make. You can easily get keyed shafts like this, and you can easily make keyed shafts like this if you have a mill. They're strong. They're easy to put together, and outside of FRC, these are by far the most common types of shafts used. They're kind of universal in machines. All right, moving on. We've also got D shafts. These are more common in FTC than they are in FRC, but they still exist. D shaft is if you took a round shaft and then sliced the top off of it or the sides off of it, it would end up kind of having the shape of a D. And that flat surface is what allows a D shaft to transfer its torque. It no longer is a perfectly round object. It has the D to transfer the torque. These are super easy to make, even more so than keyed shafts, but they're generally low torque applications because you can kind of round out that hole sometimes. They're just easy to use, but you need to have the mating D profile receiver hub for that object, for that shaft. And then there's also spline shafts. Splines look like a gear profile across the whole length of a shaft. They're usually round and have teeth. They vary from standard to standard, and they're usually very difficult to manufacture, so they're usually bought items. But they have really, really high capacity for transferring torque because there's a lot of surface area that the force is shared around. Whereas in a D shaft, you only have like a 1 contact point, and at a key shaft, you have just 1 contact point. In a hex shaft, you only have a few, 2 or 3 contact points. A spline shaft has like 10 or 20 contact points. Moving on, we've got next we're going to talk about hubs. Hubs are usually what you interface with a shaft between the component that you want to rotate. So there you go. It's an adapter that interfaces the shaft and the object that you want to rotate with the shaft. Not all things require hubs. So for example, a lot of the wheels and stuff that we use in FRC and in FTC, they have the shaft profile built into them, whether it's hex or a key. But a lot of times the wheels don't. So I know in FTC, our wheels don't have that hexagonal hub built into them. We have to add that hub bolted into there. They can be directly driven by a shaft, which is an integrated hub, those motion profiles. And hubs are just less and less used because the profiles are being added onto the parts. But I think it's an important thing to be familiar with. They generally look like these. These are FTC ones. These are FRC ones. These are splined ones, and these are hex shaft ones. This is a keyway. This is hex. This is hex. This is hex. But they're used to take the wheel that might have a round bore and attach to the wheel such that you could put a hex shaft through it, and now you can have the hex shaft actually drive the wheel. So it's used to transmit the torque from the shaft to the wheel, and it applies the interlocking feature. Next, super important topic, bearings. There's all kinds of different bearings, tons and tons of different bearings. But we're typically going to be talking about rotational bearings. And we're typically going to be talking about radial bearings. So a bearing is an element that constrains the relative motion to only the desired motion. So if you only want to make something rotate, you would use a radial bearing. If you only want to make something go in a straight line, you'd use a linear bearing, so on and so forth. There's plane versus rolling bearings. A plane bearing is like a sliding surface, whereas a rolling bearing usually has like either ball bearings like beads or like cylinders that rotate between each other. So plane bearings look something like these. These are known as bronze or oil-like bearings. They have oil kind of built into them. They're made with oil inside of them so that they kind of self-lubricate. These are super cheap, super easy to get. They're generally used on low speeds with really high loads. They don't like moving really fast. You can wear them out very quickly if you rotate very fast. But on low rotation speeds, they work really well. These are commonly used for like pivot joints. So like an arm that extends out or maybe a big arm that lifts something up. You usually use these kinds of bearings because they're lighter and they're more load bearing than like a regular radial bearing. They make the same kind of bearings in plastic as well. They're not usually as able to handle force as the oil-like ones, as the bronze ones, but they're really useful if you're trying to decrease weight and you don't have a really high load application. You could throw these in and they'll save lots of weight over time, over enough quantity. They're super cheap as well, and you can get them with flanges and without. And by flanges, I mean this guy has that little top hat shape to it, and this only has the round portion to it. This is a flanged bearing that has a flange on it. And then we have radial bearings, and these are probably the most commonly used in FRC. These are called groove bearings. They are generally really good for high loads, and they're generally made for radial, so forces towards the center of the shaft, and thrust, which is force along the shaft. They're relatively cheap. They're used at medium to high speeds, depending on the specific one that you get. And they typically have a round center bore, but you can get them in hex like this. Hex bearings are very commonly used. And similarly, they're available with flanges like this one and without flanges like these. And then we also have roller bearings, which basically bearings that have little tiny cylinders on them that you can roll around the shaft. They're also called needle bearings sometimes for really tiny ones like this. They're not as commonly used, but they're generally used if you're very space constrained. They're good for high and medium speeds and decent loads, and they can be thrust bearings as well, which means forces pushing against things instead of forces rotating about things. They usually don't have a inner race. They rotate directly on the shafts. You want to make sure you have a very round and a very hard shaft, generally speaking. And then you have mounted bearings like this, where you have a flange or these are sometimes called pillow blocks, where you mount the bearings, where you can pre-assemble that and then you can put it in place. They're usually used in very large, mostly large applications, and they're usually way bigger than what we use in FRC, though I have seen some of these on FRC and FTC robots. And that's all I've got for today. I know we're going over a lot. I know this is very dense. The lecture part of this class will slow down basically very much after next week, and it will slow down next week a bit too. So bear with me. Keep on getting into Onshape. Keep on going through the tutorials if you're interested in them. Today I'm suggesting the fundamentals of data management through Onshape, where you can learn where to save things and a little bit about version control. But generally speaking, just get into, draw some things, make some things into 3D, make mistakes, get errors, figure out how to fix the errors. Always good skills to have. And as always, let me know if you have any questions. That's all I've got for today. Emily, do you have anything to add or that you'd like to say?
Not right now, but I guess just if you're once we post these on YouTube, if you're someone watching it on YouTube, and you haven't come to an in-person class, you're still welcome to do the second part of it, which is the actual CADing together. So I'll be sending out another form for that soon, just so that we can get that stuff figured out. But yeah, I don't have. I do want to talk to you afterwards, Phil, but nothing for everyone else.
Okay, sounds good. I'm going to stop the recording then, and everybody else, you're welcome to go. Thank you.
So, Phil